There are three laws that govern the motion of everything in the universe. The first law states that a body at rest will stay at rest, and that a body in motion will stay in motion. Without a force, all objects will continue moving in the same direction with the same speed forever. Objects here on Earth slow down only because of the force from friction and air resistance. The second law states that objects change their motion when a force is applied. An object's change in motion is the strength of the force divided by the mass of the object. This means that it is harder to change the motion of objects with more mass. When all forces are removed, the object's speed will stay constant. If we watch the previous scene again, we will see that the moment Victoria exerts a force against the train instantly also exerts a force on her. This is what causes Victoria to move backwards. The two forces are exactly equal in strength, and they are in exactly opposite directions. The third law states that for every action, there is an equal and opposite reaction. When Victoria's feet move against the earth, she is creating the force pushing her forward. Victoria's feet moving against the earth also creates an equal and opposite force pushing the entire earth in the opposite direction. But because the mass of the earth is so large, the impact of this force on the earth's motion is extremely small. For larger forces, the impact on the Earth's motion is no longer negligible. According to the first law of motion, the Earth will want to continue moving in a straight line. According to the second law of motion, the gravitational force from the Sun will want to cause the Earth to fall directly into the center of the Sun. Note, in Einstein's theory of relativity, Gravity is not a force, but a curvature in space-time. This will be discussed later in this video. According to the third law of motion, the Earth will exert an equal and opposite gravitational force on the Sun. Since the Sun's mass is much bigger than the Earth's mass, the impact on the Sun's motion will be negligible, but the impact on the Earth's motion will be significant. The first law of motion wants the Earth to continue moving in a straight line. The second law of motion wants the Earth to fall directly into the Sun. The result is that the Earth follows a path in between these two options. This is what causes the Earth to orbit the Sun. Just as the Earth's forward motion prevents it from falling directly into the Sun, this is also what allows a roller coaster to travel upside down. The ball's forward motion allows it to continue traveling upward against the force of gravity. If the ball's forward motion is fast enough, the ball will continue moving along the track, and gravity will not have enough time to cause the ball to fall off. Suppose we apply a force to a rotating object. Each point on the object will want to continue moving in the same direction as before. These 2 points will cause the object to move like this. And these 2 other points will cause the object to move like this. The events shown here all happen at the same time, and this is the result. This means that when we apply a force to a rotating object, its rotation is changed to look like this. This creates the illusion that the force was really applied 90 degrees ahead in the rotation. This has profound implications for our everyday lives. Let us consider the rotating wheel of a bicycle. When Victoria leans in one direction, this creates a force on the wheel. However, because the wheel is rotating, the result is that it will appear as if the force is applied 90 degrees ahead in the rotation. This will cause the entire bicycle to rotate like this. This is why leaning causes a bicycle to change direction. It's also why objects that normally fall over almost instantly are easy to balance when they are spinning. This happens because the gravitational force always appears to be applied 90 degrees in advance of the direction in which the object is about to fall. But this will not work if the object stops spinning. This is the reason why it is easy to balance a bicycle when the wheels are spinning rapidly, but nearly impossible to balance when the bicycle is standing still. The purple sphere at the North Pole is standing still. If we apply a force and ignore friction and air resistance, the purple sphere will follow this path. Since the Earth is rotating relative to this path, the sphere's path will look like this to people on the ground. The spheres at the equator are moving faster than all the other spheres. If we apply a force away from the equator, the first law of motion will want the sphere to keep moving around the Earth faster than the other spheres. From the perspective of someone on the ground, the sphere will appear to veer towards the east. Therefore, objects moving from the equator to the North Pole will veer in the opposite direction as objects moving from the North Pole to the equator. Suppose we have a low-pressure area, and the air molecules around this area experience a force towards the center. The air molecules experiencing a northern force will veer in the opposite direction of the air molecules experiencing a southern force, causing a rotation. This is the reason why hurricanes rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. All the laws of motion are always riding with us, including the third law. As the helicopter exerts a force on the blades instantly exert an equal and opposite force on the helicopter. This causes the helicopter to want to rotate in the opposite direction of the blades. This is why a tail rotor is needed. The force from the tail rotor can be adjusted to cause the helicopter to turn left or right, or to keep the helicopter pointed in a steady direction. The tail rotor exerts a force on the helicopter by creating an equal and opposite force on the air molecules. This is the same way in which the main rotor creates an upward force against gravity. Birds and airplanes also fly by creating a force against the air. The upward force against gravity is caused by the way the air flows around the wings. Suppose that the air around a wing is standing still. The air pressure from above and below the wing will cancel out, and there will be no net force. As air flows around the wing's shape forces the air above the wing to flow faster than the air below. The air pressure below the wing is now creating a greater pressure than the air above. This creates a net upward force on the wing. This also creates an equal and opposite downward force on the air. Birds, airplanes, and helicopters work by pushing against the air. But this will not work in space, where air does not exist. In space, we need another way to create a force. As the walls exert a force on the particles exert a force on the walls. If there is a hole in one of the walls, then the forces on the walls will no longer cancel each other out. This is how rockets create a force to travel through space. Although the force of gravity gets weaker as we move further away from the Earth, this is not the reason astronauts feel weightless when in orbit. In Earth's orbit, the force of gravity is still very strong. The first law of motion wants Victoria to keep moving in a straight line, and her forward motion is the only thing preventing her from falling directly into the earth. The first law of motion also wants the box to continue moving in a straight line, and the box's forward motion prevents the box from falling directly into the earth. Victoria and the box both end up orbiting the earth following the exact same path. Since Victoria and the box are always moving together, this creates the illusion that she is weightless inside the box. This is the same way in which Victoria would appear weightless if the box were to fall from the sky. This happens because gravity is different from all other forces. If two objects experience the same force, the lighter object will accelerate faster. In the case of gravity, however, gravity exerts a greater force on more massive objects than on lighter ones. This causes all objects to fall with the exact same acceleration, regardless of their mass. Some objects fall faster than others only because of air resistance. Air resistance affects different objects differently. This is why parachutes work, and why feathers fall slower than bowling balls. In space, there is no air resistance, and all objects react to gravity in the same way, regardless of their mass. Victoria and the box therefore follow the same path and stay together. No other force behaves this way. Albert Einstein discovered that there is a profound reason for this. It is because gravitational forces don't actually exist. Here, there is no force, and Victoria is actually still just following a straight line. Objects with mass cause a curvature in space and time, causing straight lines to appear curved to us. This creates the illusion that there is a gravitational force. Different objects travel through the same curved space-time. This is why, unlike all other forces, gravity causes all objects to follow the exact same path, regardless of their mass.